Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 2nd, 2025, just yesterday. This paper introduces a new model that shows an 8.7% absolute improvement on the video MMMU benchmark, a big leap for video understanding. The paper is titled Kwai Keye-VL Technical Report, and it's all about tackling one of the biggest challenges for current AI models, which is truly understanding short videos. The authors achieved this with a massive video-focused dataset and an innovative training method that teaches the model when to reason. Also, the authors shared their work on GitHub. If you head over there, you'll find a great quick start guide. It has everything you need for pre-processing and inference, including code snippets for running the model on your own images and videos. They've also included their evaluation code, which is great. On the Hugging Face page, you can download the 8 billion parameter preview model and find code examples showing how to use it for multimodal chat with images and videos. Okay, so getting into the results, this first figure really tells the story. We're looking at two radar charts that compare Kwai Keye versus L, that's the orange line, against other top models. The chart on the left shows video-specific tasks, and you can see the orange area is much larger, showing a clear lead. The chart on the right covers general perception and reasoning, where it remains very competitive. This really validates their training approach, which uses methods like supervised fine-tuning, a process for refining a model on high-quality examples to boost performance. Building on those results, this next figure shows us the model's architecture, its blueprint. At the bottom, it takes in videos or images of any size. This visual data goes into a vision encoder, which uses a technique called 2D rotary position embeddings, a way of encoding where objects are in a picture. A projector then connects this to the language decoder at the top. This decoder uses 3D rotary position embeddings to process text, image, and video information together, adding a time dimension that's crucial for understanding the sequence of events in a video. So, how do they train this architecture? This diagram lays out their four-stage pre-training pipeline, which is designed for robust vision-language alignment. It starts by training just the vision transformer, or VIT. That's the part that processes the image. Then, they connect it to the language model and train only the bridge between them, the multi-layer perceptron. After that, they train all the parts together. Finally, they use a technique called annealing, which merges several versions of the model to create a more stable and effective final version. After that initial pre-training, the authors get to their core innovation, a special reasoning training pipeline, which we see laid out here. It starts with what they call a chain of thought cold start. This basically means they create a high-quality dataset that teaches the model how to think through a problem step by step. Then, it moves to mixed-mode reinforcement learning. This is where the model learns to switch between different modes, like a thinking mode for hard problems and a non-thinking mode for simple ones, getting rewards for making the right choice. And this table really puts that reasoning training to the test. It compares Kwai Keye versus L in both its thinking and auto-think modes, against a whole suite of other models on various benchmarks, which are just standardized tests. You can see it's broken down by task type, like general reasoning, document understanding, and, of course, video. The key takeaway is in those video sections at the bottom. The model consistently outperforms other open source models, especially in its dedicated thinking mode. This really shows that the specialized video-focused training paid off, giving it a clear edge. So to wrap things up, what we've seen with Kwai Keye-VL is a really focused effort to tackle the challenge of short-form video. The key innovations are twofold: a massive, carefully curated video dataset, and that unique training recipe that teaches the model not just to answer questions, but to decide how to think about them. By using techniques like rotary position embeddings, which help the model understand the position of objects in space and time, and reinforcement learning, it sets a new state of the art. That's all for today's roundup. Thanks for tuning in.